So, good morning, friends. Today I am taking the one more compensatory class on Unit 3 of Design Analysis of Algorithms. Already we are studied regular classes with different examples with a clear explanation, but I want to give the small presentation on important topics on this unit. So already you know this is the unit 3. Unit 3 is the greedy method. Greedy method. So greedy method is also provides the uh, feasible solution or optimal solution. The greedy method is perhaps the most straightforward design technique is to determine the feasible solution that may or may not be optional. Feasible solution means most problems have n inputs and its solution contains a subset of inputs that satisfies a given constraint or condition. Any subsequent that satisfies the constraint is called a feasible solution. What is the meaning of optimal solution? To find a feasible solution that either maximizes or minimizes a given objective function. A feasible solution that does this is called optimal solution. The greedy method suggests that an algorithm works in strategies, considering one input at a time. At each time, a decision will made regarding whether a particular input in an optimal solution. Hence, as you know, dynamic programming will give the optimal or feasible solutions. Only one decision will taken to get the result. Here, greedy method, each time decision will change, results also will changes, solution also will changes. That is the major difference between the dynamic programming and greedy method. What I am telling, greedy method each time, each decision, so the solution will be changed, right? So greedy general method. So this is the general example. Already, as you know, the procedure to write the algorithm we are seen in unit 1. So this is algorithm. The name of the algorithm is greedy. So two parameter lists we are taking here. That is a comma n. So here array of 1 to n contains the n inputs. So the solution is 0. So we are using the for loop I is equal to 1 to n repetitions. We can select the as x one element. If a feasible solution x, then solution is equal to union of solution comma x. We can combine, then finally we can write the solution. So this is a general method for a greedy approach. So there is a example, best example for the greedy approach, job sequencing with deadlines. So this is the very important for a university point of view of the end exams. There is a set of n jobs. For any job I is a integer deadlining di greater than or equal to 0, and profit pi is greater than 0. The profit pi is earned if the job completely by its deadline. They don't move to extension of the boundary. The complete a job one had to process the job on a mission for a one unit of time. Only one machine is available for processing jobs. Already we are seeing the two example problems in regular classes. You can check how we are solved the example problem. Today's class, just I am giving the general procedure to solve the job sequencing with the deadlines. A feasible solution for this problem is a subset J of jobs such that each job in this subset can be completed by its deadline. The value of a feasible solution J is the sum of the profits of the jobs in J. So that is a summation of P or total of P. An optimal solution is a feasible solution with maximum value. The problem involves identification of a subset of jobs which can be completed by its deadline. Therefore, the problem suits the subset methodology and can be solved by the greedy method. So this is the algorithm to solve the job sequencing with deadlines. Algorithm name of the algorithm is JS is represents the job sequencing. D for deadlines. J are the jobs. N is n number of profit. So this is the algorithm to solve the problem, right? So easily understand you can solve the problem, then you can get the more information how we are solved using a job sequencing with the deadline. So there is a conditions to write the solution of the this method. Knapsack problem. As you know, knapsack problem or rucksack means bag problem is a problem is a combinatorial optimization. Given a set of items, each with a mass and value, means weights and value, determines the number of each item to include in a collection so that the total weight is less than or equal to a given limit and the total value is larger as possible. So it means minimized solution, maximized profit, minimized solution, maximized. So minimization to maximization. So the capacity is the minimization, the profit is the maximization consideration we are taking in a knapsack problem. So this is the algorithm for knapsack problem. So this is also greedy approach method we are using to solve the 0 by 1 knapsack problem. So here what we are considering here is so we are having the profits and knapsack size repeatedly we are calculating the best solutions of the given weights how many possible weights properly we can insert into the bag so that is the best solution. So how many objects we are consider into the bag so that is represented with the xi is equal to 1 so which is not included into the bag is treated as 0. So when we are calculating the summation of the profit, summation of the weight, so we will multiply with the uh, value added elements into including or not including. Based on that we are getting the maximum optimal solution of the given list, right? So it means maximum capacity we are inserted into the knapsack and maximum profit also we are gained. Minimum solution, maximum profit. So this is the major strategy of the knapsack problem. So this problem can be solved branch many terms like dynamic programming also we are studied a knapsack problem. Minimum spanning tree already you know procedure to get the minimum spanning tree we are using the two algorithms, Prim's algorithm and Kruskal algorithm. Prim's algorithm is based on the adjacent of the element, minimum adjacent of element we are going to calculate construct the spanning tree, minimum spanning tree. Kruskal algorithm is the entire given graph where it is having the edges minimum cost, then only we consider without forming the loop and also covers the all nodes. So the type of construction is called spanning tree. Spanning tree means cannot form the cycle and cover the all vertices. So the type of tree is called minimum spanning tree. We are using the two types of methods, Prim's and Kruskal's algorithm to construct the spanning trees. Right? This procedure also represents same, right? Uh, for a Prim's algorithm and a Kruskal's algorithm, single source shortest path problem also, greedy method approach. To solve this type of problem, we are using the Dijkstra algorithm, right? Which algorithm we are used to solve the single source shortest path problem is a Dijkstra algorithm, right? Already we are seeing two example problems solved in regular classes. You can see and learn the more information how we are construct the spanning trees using Prim's algorithms and Kruskal's algorithm, and same as a single source shortest problem solved by the Dijkstra algorithm. Very most important topics in this greedy method unit, right? Thank you. Thanks to all.